8th grade, Algebra 1. This is Mrs. Sigley. We are moving away from quadratic functions and we are moving to exponential functions. But before we do that, I want to give you some background knowledge of what you already know that's going to help you understand the exponential function. So the very first thing that we taught you was a linear function. And that equation was y equals to x. And so in linear, it has 4 types of lines. And those lines have slopes. And there's 4 types of slopes. And that's what we worked a lot on linear, was those slopes. And so the first type of slope that you're going to have is your positive slope. And that's a diagonal line. Then we had you find your negative slope, which is also your diagonal line. Then we had your undefined slope, which is a vertical line. And the 4th type of slope is your zero slope, which is a horizontal line. So in linear, you could get those 4 types of lines: a positive, a negative, undefined, and a zero. And you had to work with a particular equation. And the very first one that we taught you was standard. And so in standard form, that equation is going to be a times x plus b times y equals to c. That was standard form. Then we taught you slope-intercept form, which in reality this is the equation of the line. So in slope-intercept form, it was going to be y equals to the slope, and we identify slope with m, times x plus b. Then we taught you point-slope form. And in point-slope form, it is going to be y minus y sub 1 equals to the slope times x minus x sub 1. And if you notice that all of them have an x, just like your parent function. So here's my x in standard form, here's my x in slope-intercept form, and here's my x in point-slope form. And so in my parent function, it also has a y. So here's my y in standard form, here's my y in slope-intercept form, and here's my y in point-slope form. And what we had you do was we had you manipulate them to go from standard form to point-slope form, from point-slope form to standard form, all of the ways. You needed to know how to go back and forth from each other. Then we kicked in quadratics. And so in quadratics, that parent function is y equals to x squared. And you knew that this was going to be a quadratic because of that exponent of 2. In linear, it does have an exponent of 1, but you're never supposed to see it or put it there. But in a quadratic, you have to differentiate, so therefore the power of 2. And so what this creates is it creates not lines, but 2 parabolas. And so like in linear, you're after slopes. In quadratics, you're after roots. And so you had 2 types of parabolas. You had a downward parabola, which you worked a lot with last week in applications of parabolas. And that had a maximum value. So downward has a maximum value, as opposed to the other type of parabola, which is an upward parabola, and that one has a minimum value. And so in a quadratic function, we then taught you a couple of equations. The very first one was, of course, standard. We always start with standard. So in standard form, that equation was y equals to a times x squared plus b times x plus c. Then we taught you vertex form. And that equation is y equals to a times x minus h to the power of 2 or squared plus k. And then last week we taught you the vertical motion form. And that equation was h equals to negative 16 t squared plus v times t plus s. And now if you notice, it also has your x. So in my parent function, there's my x. In standard form, here's my x and my x right there. It has to be squared because it's a trinomial. And then in vertex form, this is your x. And then in vertical motion form, the t was your x. We just changed the variables on you. And quadratic function, in the parent function, there's my y. So here's my y. Here's my y. And in vertical motion form, the h is my y. So you notice they're very, very similar, and they're all carrying the same variables. But now you get to the exponential function. And it's the same thing. And that equation is y equals to a times b, and it has the power of x. And that's the reason it's exponential, because the x is an exponent. Not up here like in the quadratic where you have a number as the exponent. In exponential, it's actually your x. So let's go ahead and identify a couple of vocabularies. So y equals to a times b to the power of x. The y, we know that that's your range. Nothing new. We've done that before. And that is also your dependent variable. Same vocabulary. We don't change much on you. We just like to change the names. The a is going to be your y-intercept. But I'm going to show you how to get the y-intercept, because don't just take the value of a. And of course, your y-intercept is your starting amount. But the a is also something else. The a tells you if it's a reflection. If it's a negative a, it's a reflection. And then the x is your domain. So again, we haven't changed that on you at all. And that is your independent variable. But the most important variable in an exponential function has to be that b. And b is your factor. B is your factor. And this tells you how it will grow. So to tell you how it will grow, or how it will decay. Okay. So in exponential growth, you're going to have two types. This is going to be your growth and this is going to be your dk. So, if the b, because remember the b is the most important one in an exponential function, if that b value is less than 1, greater than 1, if that b is greater than 1, then we call that an exponential growth. And that means that your graph, right here, it is going to be increasing, and it's going to be increasing really fast. That's what the exponential equation does. It either grows really fast, or it grows really, or it decays really, really fast. So, if my b is between 0 and 1, so we're talking about a fraction or a decimal, but no negatives, then it's exponential decay. And that means that your graph is going to be decreasing. So, for example, the two examples that I always think about in growth, because you're young right now, so if you put money in the bank, and the longer it's in there, because you're very young, the faster, if it's compound interest, the faster your money is going to grow, and you're going to get more money in the bank. But then let's say that you put a piece of bread out and you forgot about it. Well, then mold is going to get on that bread. And then all of a sudden, your bread is full of mold. And you're like, I just bought this yesterday, or I just got this out yesterday. So that's what exponential growth and decay do to you. But a very brand new vocabulary for you is your asymptote. And that is going to be a line to which the graph gets close but it never touches or cross. So that's what we're going to do today. So in video number 2, I'm going to show you the examples, but you need to know how it compares to a linear and a quadratic. And if you notice, in an exponential, again, I have my x value, but this time it's a power. And I also have my y value. So again, it's carrying the same type of variables as all the parent functions, but they're utilized a little bit different. So now for video number